All right. So are we iterating to play the game, to create the database file, or to ingest from the database file? Because the only one of those that's really recursive is the ingest. Ingest, okay. So first of all, let's see what this would look like if we wrote it out to a file so we can see what file we'd be ingesting. So, first we would write the root node, and then we traverse this. So I think this would be 2, 4, 5, and then 3, 6, 7. And so this is a question, question, answer, answer, question, answer, answer. So I've written it on 7 lines instead of 14. But that would be the order of the file. So ingesting this recursive iteratively is going to be really, really difficult. You're going to need to create a stack and keep track of where you are and be able to pop back to previous locations. Basically, you're going to do recursion, but you're going to do it yourself by remembering where you are and then going back to that context. And I guess I would read the first line. So I'd say, question 1. And then I would have to push this onto my stack somewhere, and I'd jump back up to the top of my loop, and I would do an ingest, which would build a node out of 2, 4, and 5. And then when I finished with my answer node, I would pop the top of the stack, which would give me this node, and I would stick this on the yes side, and so on. But definitely do ingest recursively, right? It's like 3 lines with recursion. Otherwise, you're still recursing. You're just doing it longhand. Writing to the file is recursive also. Yeah, I said just the ingest, but also writing to the file is recursive. I'm trying to decouple the A and Q from the implementation of the tree so that the tree could be database independent. So if you have just a plain binary tree, you can actually tell whether a node is a question or an answer by seeing if it has any children. If it's a leaf node, it's an answer. But the database has to absolutely somehow indicate whether each part in it is a question or an answer. Otherwise, you've just got a long stream of data with no way of knowing, if I wrote something like this or something, with a 3, 6, 7 hanging down here and so on. If we knew the tree was always full, we might be able to do that, but if we don't use that assumption, then yeah, it might be a way to do it. Definitely harder. You could have the tree be a list. Yeah, and actually we can do what we did with heaps in 222 because this is a full tree, right? We can do our index arithmetic if we want to move to a yes node. It's just the index of the root times 2. If we want to move to the no, it's the index of the root times 2 plus 1. So you could do that too, and yeah, and that would make it really easy to write out to a file. You just like write it out sequentially or something. Maybe I'll do that sometime, because this problem is fairly well plumbed online. Maybe I'll change to implementing a decision heap instead of a tree next time. Yeah, anytime. It's a good exercise. So when I learned recursion, right, we were coding something called Ackermann's function, which is this heavily recursive function, And we had to implement this in Fortran, which didn't allow recursion. So we had to, make an array and use that as a makeshift stack and keep track of where we were in the recursive call chain. And we sort of put this all together by hand. And it made it really clear what was going on, how we were moving from one point to another, how the solution of the sub-problem gets tied into the solution of the super problem, and so on. And then we were told about recursion, and we moved to Pascal, where you could do it automatically. But that's not a bad exercise to do, to take a recursive algorithm and just translate it into something that is iterative, by rolling a stack around it. Meanwhile, I'm playing with ARM assembly language. So if you like PIC processors, you would love ARM, because it's like a RISC machine, but quite a bit more powerful than the PIC, but still, very simple instructions, very reduced. Except this one's running at like 1.5 gigahertz instead of like 32K. So it's got some good horsepower. And it's got 8 gigabytes of memory instead of 256 bytes. But if you can do assembly language on a PIC, you can do assembly language on an ARM. Same concepts. And ARM is, the processor that everything is running on. It's 99 point something % of all the CPUs on the planet are ARMs. x86 is, tiny fraction. And bullet points on how RISC is can explain how it revolutionized things. Remember the old Sparks? Yeah, Sparks were awesome. And yeah, we will talk about this in 270, but really, really briefly, x86 is an instruction set with thousands of instructions. And the reason it has thousands of instructions is partially because of legacy, because they've maintained backwards compatibility through a lot of the Intel line. And so the instruction sets just get more and more complex. And as we packed more transistors onto a chip, designers were like, hey, let's make a multiply instruction. Let's make a double precision multiply instruction, right? So the instruction sets got really, really complex. And then this idea of RISC came along of like, let's just build a really simple processor with like, 20 instructions, but make it run really fast. So, x86 is a complex instruction set computer. ARM is a reduced instruction set computer. Now, one instruction on this will do a bunch of stuff, right? One instruction on this might, add a number to a register or copy a number from one location to another. But if you can do a gazillion of these simple instructions in the same time that it takes to do, a few of these, you end up winning. And so what's happened is, transistors have gotten smaller, faster, things have improved, pretty dramatically over the past few decades, and re-architecting a complex instruction set like, a Pentium processor, really, really expensive, right? Huge undertaking. Re-architecting a RISC processor, because it's so simple, relatively easy. So these have been able to ride the transistor curve a lot more successfully than these. And performance-wise, these are just, they just smoke. So that's the super duper high level version of that. There's a lot of other things that go into it, but this is what you find in cell phones, smart appliances, Chromebooks, all kinds of things like that. Pretty much everything except a laptop desktop is going to be running a RISC processor most likely, including Raspberry Pis, right? Those are all ARM based. And undocumented instructions are definitely interesting. All right, any other PA3 concerns? So office hours have gotten totally crazy. I had like 15 people in my office this morning. We managed to get through all of them, but if you have questions, much better time to ask them right now than to try to come in tomorrow morning. You can come in, but it's probably going to be pretty packed. We're also going to do open lab tomorrow at class time, so that's another opportunity to ask questions. Hopefully you're at the dotting the I, crossing the T point of PA3, because it really is, you know, it's not a 2-week assignment. It really is like at least a 1-week assignment, just to get all the parts lined up. So hopefully you're pretty close to done with that. But if you've got, you know, a nagging issue that still isn't quite right, you can come by office tomorrow at 8:45. You can do the open lab during class time. And so today I want to talk about using Swing without all of the overhead of Window Builder and Eclipse and everything else, just kind of going from the command line to give you an idea of what that looks like. And then I want to talk a little about javadoc, which is something you can use to help document your code and projects as you develop them. Yeah, we can do a run through of other versions of this. It's really common though, particularly at this level of coding, that you know you start a project, and as you develop it, what you're doing is you're finding new ways to approach it, and you're changing how you're going about it. And it's very common that, you know, partway through you start to feel like this was not the right way to do this, and you can still get it to a point where it's finished and it works and you can submit it. But very often you end up with the feeling of, you know, if I were starting this again, I would do these things differently, and that's a really common experience. And you know, if you have time and depending on what you're doing, you can go with that. You can if you have enough time while you're working on a project, you can take a few steps back and change direction, and that's really powerful for sort of conceptualizing, you know, what's a better way to organize this. And then the next project that you're working on, right, you've got the advantage of that experience, and you make different decisions up front. So yeah, that's actually a really good sign if that's been popping up for people. That's a positive thing. All right, let's play with some Swing. Let me get a window going here. So we're going to play with this today. Tomorrow's going to be open lab. Friday we'll talk about PA4. And PA4 will be a fun one. Not in the mean teacher kind of way, but in the really fun kind of way. All right, so let's make a frame. So I don't know, what should we call this? It's Wednesday. I don't know. I'll call it Wednesday. So let's make a hello world for JFrames. Not a Jello world, but a hello world. So I've got my class Wednesday. So first thing I'm going to do, I'm going to make this extended JFrame. Jello world does sound nice. It's like a next to Dolly World, or Dollywood. So let's import a JFrame. So JFrames come from javax.swing. JFrame. I'm reading chat. A high school teacher in advanced physics who defined fun as taking an oscillator, turning up the volume and going up and down with the sound while you were taking a test. Oh yeah. Well, that's a good point. Definitely. Or we can just go full bore G.I. Jane and give you like 60 seconds to eat your dinner. Yeah. Yeah. All right. So public static void main. All right. So let's construct an object of type Wednesday. Okay. So Wednesday my frame equals new Wednesday. And this is you know, not the first thing you would think to do, but you know, we're in a class called Wednesday, and what is our main method doing? Is constructing an instance of itself. That's totally legit, but you know, this might be more common if we created, you know, a separate class and we call this Wednesday, and then we had some class called myFrame, and we said, you know, myFrame, this thing equals new myFrame. But this is you know, totally reasonable to do. So we're constructing an object of type Wednesday, and we're calling it myFrame. And I'm going to say myFrame.setVisible true, so that we can see this thing. And there's my program. So let's compile that. Let's spell true with an E. Let's spell myFrame correctly. Alright, so let's run this. And I'll say Java Wednesday. And if I go way up here in the corner of my other monitor, there's my JFrame. Right, so I got a tiny little JFrame sitting here. And if I grab a corner and I expand it, right, it's a full-blown JFrame. And, you know, 2 lines of code to construct that. Alright, so it doesn't take a lot, right? Now when I close that window, my program didn't exit, it's still running. I can Control-C it to kill it, but I didn't actually cause it to exit. And, you know, I could have done this in a single line by just saying new Wednesday, set visible, true. And same thing, there's my little JFrame. Right, so this constructs an object of type Wednesday, which is a JFrame, and then we set the visible property to be true. Java X is like Java, but extra good, like the X. No, I don't know what the X stands for, but you see it a lot for things that are related to windowing. But if I look at the Java page for JFrame, it tells me it comes from Java X, swing Java. But what is Java X? Package of standard Java extensions. Okay, so it is like the extra. It's extended. Yeah. All right, so that's kind of a minimal example to get a frame up, but it's not a terribly useful frame. So let's make this thing more interesting. So let's set the bounds. So if I run this, I get a window over here, and there's my 100 by 75 window, and it was sitting up in the upper left corner of my monitor. And so if I put it at, say, 5100, let's put it at 4100 and 300. All right, so now it's popping up like on my second monitor. I guess I'll make it a little bigger. So we'll go VGA style. There we go. All right, so we can start adding things to this, right? So for example, you know, it would be nice if when we close out the window, it exits the program, so we can put that in. Set the default close operation, JFrame exit on close. So if you look at the JFrame documentation, there's a bunch of static fields. One of them is called exit on close. And we're using that to access the set default close operation as an argument to that. So if you look at set default close operation, right, it's a method inside JFrame. What's the argument? It's just an integer. But what integer do we want to pass to that? Right? Do we want to pass the number 5 or the number 1 or 0? What's the correct integer to say exit on close? Well, I don't know, and I don't have to know, because this same class defines some fields which are integers, such as such as exit on close. Right, so that's, if I use the name of the class, jframe.exitOnClose, that's an integer. Now I could print it out and see what the value is, but I would never want to code that value right in here, because on a different version of this class, that value might change. Right, but as long as I'm calling exit on close, I should be good to go. All right, so now if I run this and I close this window out, my program exits. All right, so that's sort of the basic setup. Let's add a button. So let's use a J button. That also comes from Java Swing J button, and let's do the following. All right, so I construct a new J button called B, which will say click here. And that compiles, but it's not going to do anything, right? I've created a button, but you know, it's like creating an int. It doesn't change what you see unless there's a reason for it to. So we have to put that button somewhere where we can see it. Okay, so one way to do that is to add it to our frame. So my frame.addB. And now I got a button. It says click here. It happens to be a really big button. It's taking my entire JFrame, and if I make my frame big, my button gets really big. Right? Why is it taking up the whole space? Because there's only one thing on there right now. So there's not really a panel on here. You can add components to a frame, but it's pretty uncontrolled. So the usual setup is something more like this. So we have a JFrame, which is a window that has some buttons up here and a button up here, and it can have a title and so on and so forth. And we can put things in here, but the more common thing to do is put inside here another container, which is called a jpanel. And with a jpanel, we can add, a window manager. And then we can start putting components and control where those are placed and how they change relative to one another and so on and so forth. Now, this is a JFrame that I'm sitting inside, right? So my frame is a JFrame. So, I can do things like set the title of the JFrame. Right, and so I've got a little title sitting up here now. Alright, so we've got a button. Normally I would put it on a panel, I would put down a window manager maybe, I would control its position by using a set bounds method or set its X and Y position and so on. But I'm just kind of going default. Alright, so let's make it do something when we click the button. And all of this is just kind of for your own information for what sort of the minimum set of code is to do the things that we're doing. But you're going to use Window Builder probably for PAs 4 and 5 and other stuff beyond this course, or something like Window Builder, which will do a lot of this for you. But just to let you kind of see like what is involved and how little is involved, let's tie an action to the button. So, I'm going to create something called a myListener. This is a class I'm going to create. And myListener is going to be a class, and ML is going to be an object of type myListener. And to register that I want something to happen, in particular when the button is clicked, I'm going to use a method in the button called addActionListener. And the argument to this is actually an object of type myListener. So I'm going to pass this object ML. So when the button is clicked, certain methods inside this object ML, this class myListener, certain methods will get executed, depending on what happens. If you click, if you get focus, and so on and so forth. All right. So this is all I need to do to create that action listener and associated with the button. And this is stuff you find, by looking in the documentation. So, let's make a myListener class. And the method that's going to be called when this action is performed is called action performed. So I'm going to say public void, well, I can't type. So public void action performed, and it's going to take an action event. I'm going to call it AE for action event. And I'm just going to say click. All right. So here's the setup. This is a method in the button class, the JButton class, right? And running that method says for this button, when it's clicked, go ahead and execute the action performed method from this object. So in other words, run ml.actionperformed. But this only works if ML is a very particular type of an object. It's got to be what's called an action listener. Okay, so what I should do over here is I should say this is an extension of an action listener. But we do something a little different with listeners. Instead of extending, we use a keyword, which is implements. Implements is basically like doing an extension, except the class you're extending is what's called an abstract class. It doesn't actually have the body of any methods written in it. It has an outline for the methods that you can write or implement when you extend or implement this base class. So I'm going to say class myListener implements, I just want to put that letter in there, implements action listener. And so now, you know, it's basically extending this, but I'm putting in my own version of the action performed method. And my version is going to say click. So now when the button gets clicked, it will look inside this object, which is a myListener, which is basically an action listener. It will look for something called action performed that takes an argument of action event, and it'll execute that code. So I need a pair of imports. So I need java.awt.event.actionEvent and java awt event action listener. Oh, I didn't like that. Public void action performed action event. Look at all those errors I got for like one thing wrong. Did I do AVT? Whoa. Thank you. Much better. Alright, there we go. There's our widget. There's our button. Click the button. Hey, it says click. All right, so that's you know, that gets you on the air, and it's not bad developing, you know, more complex code from the command line, you know, just using VI or simple non-IDE, and making the stuff yourself if you really want to learn what the elements of Swing are and how they work together and so on and so forth. We're not really trying to learn Swing, we're trying to learn object-oriented programming. So we're using Eclipse Window Builder. We don't have to worry about this, but I think it's useful to see sort of how little it takes to actually get something up and running. So that's kind of what some of this stuff is that's going on behind the scenes. Now, when you do this with Window Builder, you don't get a separate class called myListener, right? What you get is a bunch of code that defines the whole class and the method inside the argument to add action listener. So so the code we were playing with the other day, when you add, well, this is a change listener, but same idea. When you add the listener, right, the argument to that, instead of being an object constructed of a type of something that was, you know, an instance of a change listener in this case, the whole declaration of that class and the corresponding method is inside the parentheses of that method call, right? So that's an inner class, and it's an anonymous class because it's not named. So that's a shortcut way of doing all of this and that. And we do it enough that it's nice to have those shortcuts. right, so let's hop into Eclipse. And let's talk about Java documentation. So let me see if I can find a fraction class. Alright, so we're going to do some really horrible code here. Alright, let's close this out. That's not what I meant to do. Sure. So let's make a new Java project. Call it Wednesday PM. Let's make a new class. And let's call it fraction. And I'll type really fast. Oop, I typed in the wrong place. Alright. I don't know if this would run or not, but anyway, here's some fraction class that I wrote a while back. So, right, we're familiar with this. So I've got a public class fraction, and I've got some comments up here, right? So I'm going to write my comments differently, okay? We're going to use something called javadoc. Javadoc is basically a markup language. And the idea is this: we can write comments in our Java code in such a way that we can run a tool called javadoc that will take those comments and produce some documentation for us. Okay, but only if we put those comments in a very particular format. So the way we usually start this is we write our comment. You know, you can write comments by saying /* and then a / at the end, or you can, you know, do //. Now if I start a comment with /*, and I hit enter, it fills in some extra lines for me, and it gives me a block of text where I can start typing. So I can say so here's a class that implements rational numbers, which have an integer numerator and a misspelled denominator. And it puts in this thing that's a tag that says author Nick. All right. And so here's a constructor. Let me put a message, a comment in the beginning of this. Construct a fraction by specifying both the top and the bottom. And it notices that my constructor has two arguments, n and d. And so it's made a line that says @param n, and what I can do after this is I can type a description of what that parameter is. Numerator of the fraction to make, and this one I can say denominator of the fraction to make. And so, you know, I'm documenting this the way I've been asking you to document, where in the beginning of your methods, you have a comment block that describes, you know, what this thing does, what the inputs are, what the outputs are, and so on and so forth. But if you do it in this way, and let me just do a few more of these. So I'll do a /*, and this is a default constructor for n/1. And n is value of fraction. need to like change my shortcuts. And let's do a couple of more of these. Let's document the GCD function. So /**. So what does this do? Calculate greatest common factor of two integers. Parameter A, first integer. Should be greater than or equal to B. It doesn't really matter. I'm just putting some stuff in here. Second integer, return positive GCD of A and B. All right, and you can go on. You can do this for all of your functions and every every method. You can put it in for the fields. You can put it in for the class, and you can do this for all of your classes. Okay, why do we want to do this? Because once you've done this, I can come up here under project and I can say generate javadoc, and I'm sitting in this class fraction, so it's going to make documentation for that. So I'm just going to say finish and yes to all. And I have a new tag under here called doc. And if I look in here, there's a file called index, and if I double click on that, it shows me, so I can look at HTML in my Eclipse window. There's my javadoc for my fraction class. So it describes it, and I'm going to bring this up outside of Eclipse. What did I call this? Wednesday PM. So it created all of these files for me, and let's just run Firefox on index.html, and there's documentation on my fraction class. So the name of the class, which is inherited from, brief description of it, author is Nick, constructors, so construct a fraction by specifying both top and bottom, there's a method GCD, there's a method toString, and so on and so forth. It's all hyperlinked. You can click through and read the descriptions of these. And it presents it in a standardized format. And it's exactly the same format that the Java classes are described in. That's swing and string and math and all these other stuff. And this can be useful. And if you have multiple classes, they'll be listed over here. And you can click through to any of those, and so that's a useful feature. I'm not requiring this, but it's a nice way to take the code that you're developing, and if you're being forced to put comments in anyway, you can do them like this, and then really for free you get this beautiful documentation out of it. And you don't need to do this from Eclipse, right? From the command line. From the command line, you can put your comments in like this, and then there's a javadoc command you can run. You just say javadoc and the name of the Java file, and you get the same collection of HTML pages popping out of that. So like I say, it's a markup language, and there's a small set of tags you can use for this. So you can say author to name the person who wrote the code. You can say parameter for listing the arguments to a method or a constructor. You can say return if the method returns something. Mark things as deprecated, link to other things. If you throw exceptions, you can tag that, and it just comes out with a uniform look and feel. So so that's a fun thing to play with. All right, so Open Lab tomorrow. Friday we'll talk about PA4, and then the next thing we need to tackle is how to actually do drawing on a widget. So we have our JFrame or our jpanel, and we can place buttons and text fields and things like that. But how do we actually draw a sine wave or some lines or whatever we want to do? How do we go pixel by pixel, or sets of pixels like lines and circles, to create pictures on here? And that's going to involve overriding some methods and extending classes and a deeper dig into those concepts. So we'll do that next. It's not actually coming out as a vector, but we'll draw it as if it were. Right? We'll say draw a line from this point to that point. It's still rasterized on most displays, but yeah, we think of it as vector. All right, cool. Have a good afternoon. I will see you next time.